Okay, we're going into the next section in chapter 4, which is parallel lines. So parallel lines, here's like your key concept or your definition, but I think for the most part, you guys know what parallel means. It means that they have the same exact slope. So for example, in equation form, if I have y equals 3x plus 4, 3 is my slope. If I have another equation, y equals 3x minus 1,000, 3 is also my slope. Since they both are 3, those two lines are parallel. It doesn't matter that they're very far apart because their y-intercepts are, 996 units away from each other. It just, as long as they have the same slope, that's all that matters. And visually, we know what parallel lines look like. If I was giving you a graph, you were able, most likely, to tell me that it's two lines that never intersect and go on and on forever. So we're going to be creating parallel lines. I'm going to give you a point, I'm going to give you a slope, and I'm going to ask you to create an equation from it. So yesterday we were talking about point slope form, and the day before talking about point slope form, and that's exactly what you're going to be using. So just a reminder, point slope form. Slope form is y minus y1 equals m times x minus x1. If I'm just writing an equation, I need an x and y point. Well, let's highlight it, it's easier. An x and y point and a slope. Well, the question says write an equation of the line that passes through. Here's our x and our y point, but it says is parallel to this equation. Well, if it's parallel, it shares the same slope. So even though they give me this whole equation, y equals 3x minus 1, I really don't care about any part of it but the slope. As if none of this exists. I just care about that slope because that 3 has to be in my new equation because these two equations are parallel. So let me erase all the scribbling I just did. So yesterday I gave you a point and I gave you a slope, you put it in here. Now I'm giving you a point and I'm giving you an equation. You just have to identify the slope. So 2, plug in point and parallel slope. Parallel, let's see if I can spell parallel. So in this case, my parallel slope is 3. So I'm going to do my side work over here. So y minus my y value, which is negative 5, equals my slope, which is 3 now, coming from the other equation, x minus my x value, which is negative 3. Let's simplify this. By simplify, I mean make sure if you have two negatives, they make a positive. And now I want to make a whole equation that's similar to the equation that they gave me. So I need to distribute this out. And get it into y equals mx plus b. So I'm going to distribute 3 times x is 3x. 3 times 3 is 9. I start combining my alike terms. So I subtract 5 to both sides. So y equals 3x plus 4. So this equation in blue and the equation they gave me, y equals 3x minus 1, those two are in fact parallel. 1, I could tell because they have the same slope. But 2, if I went over here and I graph this bad boy, so here's my blue line, starting at 4, going up 3 to the right 1, or going down 3 to the left 1, I'll have this blue line, y equals 3x plus 4. If I have this black line, which is the equation that they originally gave me, y equals 3x minus 1, I begin at negative 1, I go up by 3 over 1, or down by 3 to the left 1. Doesn't matter that they have different y-intercepts, they are still parallel. So very similar to what we just did the past 2 days with point slope form, except now I'm giving you an equation and you have to identify the slope that we're plugging in. All right, so here's my new example. Write an equation of the line that passes through -2, 11 and is parallel to the line y equals -x plus 5. So remember, we're plugging into point slope form because we're giving a point and a slope. So why not use the one formula that has both words in it, point and slope? I have my point, it's obvious, it's in front of me. What is my slope going to be? My slope, I'm just looking at this equation, is a negative sign, but it's actually a -1. And I don't need any other part of this equation. I just need that -1. So now when I plug in, I have y minus 11 equals -1, x minus a -2. Start simplifying. Y minus 11 equals -1 times x plus 2, because remember, it's always the opposite sign. This is a -2, and my formula becomes positive. It's a positive 11, and my formula becomes negative. And now we're going to distribute. -1's being distributed inside the parentheses, so I have -1x minus 2. Combine like terms, so I add that 11 over to the right side. I have y equals -1x plus 9. And we don't have to put the 1 there. You could put just the -x. That's fine too. Oh my gosh, this pen keeps disappearing. There we go. Either or is correct. And then I compare it back to the original equation they gave me, and I look to make sure that my slope here and my slopes here match up. And they do. So that tells me that I did create a line that's parallel. Write the slope-intercept form. So our final answer should be y equals mx plus b of the equation of the line described. Through 0, -3, parallel to y equals -4/5x minus 2. So same thing we're doing that we just did in the last two examples. First, we're going to plug into point slope form. So I need to identify my x, my y, and what is my slope that I'm going to be using. You are correct if you said -4/5. That's going to be my m. So I'm replacing in my equation. Y minus -3 equals -4/5 x minus 0. Condense this right here. I see two negatives. I make them a plus. And now, oops, not a plus. Now I can start distributing. So I'm going to distribute that -4/5 inside the parentheses. I get y plus 3 equals -4/5 x. And then anything times 0 is 0. So I'm going to just put 0 there. And I'm putting plus because this is a negative and that's a negative. So it technically does make a plus. I'm going to combine like terms. So I'm going to move this 3 over to the 0. That's why I put it there, to remind myself, hey, there's technically a place over here for this 3 to go to. Don't forget about that. So I'm left with y equals -4/5 x, and then 0 minus 3 is -3. All right, let's look at this guy together. Put both my equations up there so you can compare. I label my x, my y. What's my slope that I'm going to be using? You're correct if you said negative 9 over 5. Let's plug into our equation together. Y minus a negative 5 equals negative 9 over 5 times x minus another 5. Simplify, so this should be x plus 5 equals negative 9 over 5, x minus 5. Now I'm going to distribute just like I did in the other problem. Y plus 5 equals negative 9 over 5x. What does negative 9 over 5 times negative 5 simplify to? My 5's cancel out right here. And a negative is a positive. So the only thing you're left with is a 9, and it's positive, so plus 9. Combine like terms, what should my final equation look like? Here we go. Negative 9, y equals negative 9 over 5x plus 4. Not so bad, right? It's very repetitive, same steps over and over again. We should be getting very comfortable with this point slope form. All right, last two questions we're going to do together. Hold on 1 second. There you go. Sorry, my cat was scratching at my door to come in. Create an equation parallel to the two given points. So, and it says right in slope-intercept form, I added that in there. So the previous problems I gave you a point and an equation, and you had to identify the slope. Here, these guys, just like you did the other previously, you're going to have to find the slope, which means I'm going to have to use, yet again, the slope formula between 2 points. I label my points x1, y1, x2, y2, and I start plugging in y2 minus y1, negative 10 minus 14. Then I have x2 minus x1, 20 minus 18. Negative 10 minus 14 is negative 24. 20 minus 18 is 2. I can simplify that to negative 12. So my slope that I am going to write an equation for that will be parallel to it is negative 12. So now I have to pick one of these points, any point up there. I'm just going to pick, I'll pick the second one because there's zeros in it. And I'm going to plug into point slope formula. Y minus a negative 10 equals my newfound slope, x minus my x value, which is negative 20. Simplify. So I have negative 12, x minus 20. And now I'm going to distribute. So I have y plus 10 equals negative 12x, and a negative 12 times a negative 20. Let's see what that is. Oops, not that. Times 20 is a positive 240. I subtract 10 because I'm combining like terms. So y equals negative 12x plus 230. Large y-intercept. Well, that's all right. Doesn't matter. My old notes are on here. Same exact thing we're going to do for the second problem. Use the formula y2 minus y1 over x2 minus x1. We're filling in my and labeling the points here. x1, y1, x2, y2. I have positive 4 minus a negative 20 over negative 3 minus a negative 11. Sorry, my cat is going to town scratching things. A little board back there. So I apologize if you hear it. It's very disruptive. Two negatives make a plus. So I have 4 plus 20 is 24. Negative 3 plus 11 is 8, sorry. And 24 divided by 8 is 3. So this is my new slope, and now it's very similar to the previous day where you pick a point and plug it in. I'm going to pick the second point because it's smaller numbers. That's my rationale. Y minus my y value is 4, equals my slope, x minus my x value, which is negative 3. Simplify that bad boy. And now distribute. Because I want my final answer to be in slope-intercept form. 3x plus 12, and then I'm going to add that 4 over to combine like terms. Y equals 3x plus 16. And I am done. So not too much, not too different than the previous lesson. The only difference now is if I give you an equation, we just are looking at the slope. I don't care about the y-intercept of these equations at all. I'm only focused on that slope.